Hello, friends and students. This video series as well as channel to help the students on hobbyist who are interested into have or want to go for a industry, work in the industry, okay, and who want to have a practical knowledge, hands-on practical knowledge on different type of circuits, components, and technologies. So I will be making a series of videos in this thing, very short videos I've been making, as I've told you in the first video. Electrical industries, electronic industry, and also it will be helpful for the students who are from instrumentation background. Okay, please remember, nowadays it is very important for the industry, because the industry, they are looking for the students or the workers who are skilled, already skilled, who have a practical knowledge, who have already some ideas, because it will save their time and their effort also. Because if you go to the industry, if you start giving them, they will start giving you training and all. It takes a lot of time. So what they do is, nowadays, what is the trend now? They want students who have already knowledge of practicals. So this video series are for those students who wants to join the service as well as manufacturing industries. What is actually required for the industry? That thing I'm just telling you in this particular videos, and I've been making these videos. I sincerely want that you should also like, support, that is, you should also spread, share, subscribe to this video so that it reaches the maximum of the students. Okay, so that is, finally, I have told my name. My name is Bipin. I have 35 years experience in industries, both in manufacturing as well as service industry. So happy learning practicals. Thank you. All right, friends. So we have come to the next chapter, that is working principle and testing of passive and active components. So here we will see why the components, how they work, why it is there in the circuit, and how to test them. Okay, this we will try to cover in this particular topic. So I will just go through the slides. We call it as resistor. All right. So resistor we'll discuss. On the top, you can see a capital letter R has been written, and the symbols are given. Can be in a box form or it can be in a zigzag form, right? These are the symbols. So compulsory you have to remember, wherever in schematic diagram it is given, yeah, it is a resistor. Now we'll come to the definition part. Okay. So definition, why we use resistor, what does a resistor do in a circuit? Right? Circuit or current in the circuit. Right? What it will do, it will resist it. Okay. So what happens after resistance? The voltage will drop naturally. The voltage will be dropped. So wherever you want to have a voltage drop, we'll be using a part called resistor. Okay. This you have to remember. The resistance is very important part. Resistance is measured in ohms. That is the value. Okay. What is ohms? He was a scientist. Okay. The law states that the resistance is equal to the drop of voltage across the terminal. It has a two terminal drop of voltage across the terminal. Okay. The Ohm's law stated that. The SI unit, I told you, it's a ohms symbol. It's a Greek symbol. SI unit, we call it as omega. It is shown, right? And symbol of resistance already you have seen. On the right hand side, you can see how does a resistor look. There is some colors are over there, and you have two resistor connected as a potential divider. Okay. We'll go to the next slide. Type of resistors: fixed type, variable resistor, or fixed type. Two types. Fixed type, it will have only two terminals. Variable type, it will have three terminals, or maybe in some cases it will have only two terminals. Like LDR and all, it will have two terminals, because when the light falls on it, the resistivity changes. All right. So specification of resistor, what you have to remember in resistors, first is value. How you will find out the value? With the help of a color code. Okay, the bands, the first band, the second band, the third band, and the fourth band. Okay, so hope you have already studied in theory in the classrooms what is how to find out the value of the register. Okay, so we'll not discuss about that. So value of the register can be found out with the help of a color code. Second part is power rating. Power rating means very easily you can find out the power rating, that is the size of the register. If it is bigger, higher, that means the power rating is more. You can see on the bottom side, some pictures are there, 20 watt, 10 watt, 5 watt. The sizes are slowly, gradually reducing. That means the wattage, if it is coming down, the power, the size also comes down. Okay, right, tolerance. In the color code, the last value, the last ring, it is given as a tolerance. Mostly you will find two rings, gold and silver. That is, gold stands for 10% and silver stands for 5% tolerance. Okay, right. Then comes the temperature coefficient. You don't have to bother because industrial grade, they will use a carbon film or they will metallize film. Metallized film will have a good tolerance, or the temperature coefficient will be very high compared to carbon film. Carbon films register are cheaper than metallized films. So depending upon the industry and sophistication and the requirement by the circuit, what type of resistors, whether the carbon or metallized film, they will be using, right? So this variable resistor, three terminals as we have decided: potentiometer, trimmer, rheostat, photoresistor, thermistor, varistors. These are all categories of resistors. Okay, right, student. So in this practical, I will just show you how I have connected a circuit, like 2-3 circuits I have connected and how it is working like. So you can see first I have given a supply voltage of approximately 4 volts to this circuit, and you can see two LEDs are glowing. Okay, but you can see, just make it out. In this two LEDs, one is brighter and one is lighter. What is the reason that I'm going to tell you? Okay, so what I will do is, this is negative of the supply and this is positive of the supply, that is coming from the battery. So what is the voltage? Approximately it is 4.03. Okay, right. So one LED which is lighter, let's check what is the voltage on that particular LED. That is how much voltage it is going. It is showing 1.73. Okay, and just which is brighter, we will see what is the voltage on that particular LED, how much it is going. So we are seeing that it is 1.89. That means the which is a brighter, you are getting more voltage. Why it is happening? Because the resistor value, this and this, these are the two resistors I have connected. So one is 10K value where I have connected, that is the reason why this LED is not brighter, and 1K value resistor, the LED is brighter. That means there is a less opposition and more opposition. The value, if it is more, that is 10K is more, the opposition to the electron flow or voltage will automatically reduce. Okay, and here the opposition is less because the value is 1000 ohms or 1K, we call it as, right? So this is one practical I just wanted to show you. I have connected two resistors here. You can see this resistor and this resistor. Okay, so now what I will do, this is in series. Already we have discussed in another class how it is to be connected in series. That is, one end of the resistor should go to the one end of this thing. Okay, we'll just reduce it. The value of both the resistors R1 and R2 is approximately 1K. So 1K plus 1K, it is coming to be 2K. Approximately it is showing 1.93. It's near about 2K only, right? So what happens in series? This plus this. That means R1 plus R2, the value is added. Same thing you can see here. I have connected two resistors in parallel. You can just make it out here. This 2 points. This is connected in parallel. The value of each R1 and R2 is approximately 10K. So what will happen? 10K 1 by R1 plus 1 by R2. Okay. So 1 by R1 and 1 by R2, what should be the value? It is coming approximately 4.92 or 5K. So 10K has become half when it is connected in parallel, right? So these 2 points you have to remember: series and parallel. Series, the added value, and in here, parallel, it will be divided. That means 1 by R1 and 1 by R2, or if it is 3 raised to 1 by R3 also. Okay. Now I will show you one more thing. This is about, what 2 resistors I have connected here. Okay. So I will just show it to you. I'm just connecting negative point of this to this place. Okay. And I will just put it to voltage range again, my multimeter. And you can see here, one 10K resistor from negative to this point, and from there, one more 10K resistor, which is connected to the positive, right? So one side 4.4 volt approximately, another side it is 0. I will just try to show it to you. So this is the supply voltage given to this two end of the resistor. Okay, it is coming approximately 4.04. Okay, now I want to check the value which is in between. In between means after this, and which is connecting to another resistor. Suppose R1 and R2. So R1 and R2 joining place, what is the value? Right? It is approximately 2 volts. So why it has come to 2 volts? Why? Because exactly same value resistor, same value opposition I have given. So it was 4 volts. Now it is 2 volts. This arrangement, we call it as potential divider or power divider circuit. Okay. This circuit is very important. We use it in transistor based biasing circuits and other this thing, in which we'll see in the current future. So why this is important, I just wanted to tell you. Series, parallel, drops and all, you should understand basic function of the resistor. Okay, why we have connected in series, why we have connected in parallel, what happens to the value, where it will drop, what if the resistance is more, there is a more opposition, if the resistance is less, that opposition is less, and what is power divider circuit.